4.4, characteristics of graphs. Okay, starting off, we have the domain. When you hear me say domain, I am only talking about the x-axis, okay? So this is your x-axis pathway is what we're going to call it. And we're always going to go from left to right. It's going to be in a coordinate, left to right, your left bound, right bound. Range is going to be similar, but it's your y-axis. So the pathway of your y-axis. And it's going to be from the bottom to the top. So we start with our negative values, we end with our positive values, okay? So bottom to top on the y-axis. Then we have our x-intercept. This is where I cross which axis? X, where I cross the x-axis, and y is going to equal 0, right? Remember that?
No.
What's the y-intercept? Where I cross the y-axis. Same thing as the b value, right? And it's where x equals 0. Good. All right. Next up, we have what we call our end behavior, okay? And this is going to be a really, really big part of what we're doing today. This is going to be what your Delta Math assignment is over. So we've got to make sure that we understand it. But what I want you to write right here is where your graph is headed. So where the graph is headed, and we'll explain that better when we get there. And then we have our increasing and our decreasing intervals, okay? So what I mean by this is when your y value is increasing or decreasing, so going up or going down, we need to know what x is doing. So what is x doing? So when y is going up or down, is x going up or down? Or is x stopped at a place? Okay. Anybody need more time with that? Yes? Okay. All right, so our first line here, we're going to start off with just domain and range, okay? So everybody sees this line. What you can't see, though, is that this graph has a line going in each direction forever, okay? So this is going to the left forever, it's going to the right forever, it's going up forever, and it's going down forever. Do we all see that?
Yes.
Okay. So when we're talking about domain and range, the first thing is just domain. And when I talk about domain, the only thing I care about is the x-axis. So the pathway that this takes on the x-axis, okay? So do we all agree that this is going to the left forever? Yeah. We can all see that. So we're starting off left forever. Where's the right going?
Forever.
Forever. So that's also infinity. So the domain of this line is negative infinity to positive infinity. Okay, the range. Again, this is bottom to top. So do we agree this is starting at down forever? So it'd be negative infinity. And it's going up forever. What is that?
Positive infinity.
Good. For domain and range, here's one thing I do not want to see, and I will mark it wrong on your test, and Delta Math is going to mark it wrong on your homework. You will never have a domain and range that starts with a positive infinity, ever. That's never going to be your left bound, okay? It's always going to be negative if it starts on the left. Same thing with your right bound. You are never going to see negative infinity on the right, because you're not going up and you're not going to the right to negative infinity, okay? So I don't ever, ever, ever want to see that, ever.
On both of them?
Yep, so I don't want to see this on the left, and I don't want to see this on the right. So make sure you're aware of that. Negative is always going to go on the left. The positive is always going to be on the right. So now we got this parabola. You also hear it called the quadratic. We'll actually graph these next semester. So if I look, is my domain left to right or up and down? Or down to up?
Left to right.
Left to right. That's what domain is. Okay? So looking at this one, it's a little hard to visualize. But from left to right, are these going left to right forever? It is. Negative infinity to positive infinity. Okay? Even though this is kind of narrow, it's still actually going to the left forever and to the right forever, even though it's just not very wide. Okay? Range, though, is going to be a little different on a parabola. Is this going down forever and up forever? No. Which one, though? Yep, negative infinity, comma 5. Good. So it's going down forever, which means negative infinity, but it's stopping at the 5. Stopping at the 5. Again, we just care about the y-axis, so don't tell me that it's stopping at negative 1, because that's where it stops at the, or that's the x value of where this stops, okay? But make sure you tell me the y value, okay? Questions on that? All right, I want you to try this one. It's going to be very similar to the other. From the left to the right. What's this one doing? Negative infinity to infinity. Good. Absolute values will always be that for the domain. And then the range. What do we think here?
3 infinity. That's probably wrong now.
3 to infinity. Good.
So
it's
answer this, but I wasn't paying attention. Why do you have to do that one?
the bracket,
Yeah.
because it's also equal to 3. Okay? Because it's not an open dot there at the bottom of that. Remember? So we use the bracket instead. So this is 3 to infinity. Good. Questions on that? Anybody confused on domain or range? No? Okay. Next up, we have our x and our y intercepts, okay? We can determine these algebraically by plugging in our zeros. However, they gave it to us pretty easy on this. They went ahead and graphed it, and we just have to tell the points. So if I look, what's the point where I cross the x-intercept?
2.
No.
I don't.
Negative 3, just about. I'd probably call it like negative 2.5
Oh, I'm an idiot.
when y is 0. So I have to write that as a coordinate point. When it's an x-intercept, it'll have a number and then 0. Okay, now the y-intercept, what's that going to be as a coordinate? 5, 0 or 0, 5?
5, 0.
0, 5, because remember it switches. X-intercept has y equals 0. Y-intercept has x equals 0. Okay. Go ahead and do the next two for x and y intercepts. Is it possible for a function to cross the x-axis twice? Yep, there's a hint. All right, x-intercept or x-intercepts. How many am I going to have? 2. It crosses that x-axis twice. What's the first point?
Negative 2.5.
That works. Negative 2.5, comma,
0.5.
0, right?
What?
That's the point. Negative 2.50 right here. And then 0.50, good. Or if you put a different decimal, you might have done like 2/3 or something. But those are my 2 points. What about my y-intercept? 0, 3, good. 0, 3. Questions? Okay, x-intercept. Do I have one? Why? Yeah, these lines are going up forever, right? So I'm never, ever, ever going to cross that x-axis. So that I'm just going to write none. You could write no solution, whatever you want to do there. None works. And then our y-intercept. 0, 5. Good. Questions on that? Everybody good on that? Okay. Don't just write none on every blank, okay? Make sure you actually look if it's going to have that intercept or not. Okay, this is the end behavior. And I don't actually love the order that this goes in, okay? So I actually want to flip these. But we'll just go ahead and do them in the order that they are, but we'll flip them later. So the first thing it asks is what is happening on the right side of the graph. We're usually going to start with the left side just because we always work left to right, but that's okay. So what I want to know is what is the furthest x value that can be graphed on the right? And when that happens, what is the y value doing? What is it going to reach? Okay? So usually on pretty much all of them that we're going to do today, we're looking at as x approaches infinity for the right value, what is y doing? Is it going up or down forever? Okay? Well, we don't know yet because we haven't had any examples yet. And then same thing for the left side. As x approaches negative infinity, where is y going? Okay? But we're actually going to start with the left and then do the right. So what I want you to do here is write negative infinity and positive infinity in these two blanks. So as x approaches negative infinity, f of x is approaching what? And same thing as x approaches infinity, f of x is approaching what? Then what I want you to do is just like what we wrote on the other one. Remember that my x-axis goes from left to right. My y-axis goes from bottom to top. So if I look here, as my x, okay, so if I look on my line, as x is going to the left forever, is y going up or down forever?
Down.
Down forever. So what do we call down forever?
Negative infinity.
Negative infinity. Okay? Now we're going to do the opposite. As x is going right forever,
Positive infinity.
y is going up forever, which is positive infinity. So we're going to write that in that blank. Questions on that? Okay. Next one. Same thing. So as x goes left forever, as x goes right forever, I want you to tell me what is y doing. Okay? Don't shout it out, but just look. Okay, so as x goes to the left forever, where's y going? Down forever, which is negative infinity. Does everybody see that? So as I'm going to the left with x, y is going down. Okay, now as I go to the right forever, so as x approaches positive infinity, where is y going? Also down. So we're going to also call that negative infinity. So those should look just like this. Okay? Now I want you to go ahead and try this one. So that first blank, as x approaches what? Negative infinity, because again we said we start with where it's going to the left, so it's going left forever. What's y doing? Yep, it's going up, so it's going to positive infinity. Then as x approaches what? Positive infinity, because x is going right forever. What'd you say? Yep, y is also going up forever, so it's going to positive infinity. Questions on that? Anybody confused on that? Yes? Okay, so what these mean, as x approaches negative infinity, which means as x, if I label these, my x-axis, I know negative infinity is to the left, okay? My y-axis, I know it goes like this. So as x goes left, approaches negative infinity, do you see how y is going up to positive infinity? Yep. So that's why it's the second blank. Okay, and then the same thing as the other side. As x goes to the right, it's approaching positive infinity because it's going right forever. It's also going up forever. Okay? Does that answer your question? Cool. Any other questions on that? Okay. Next up, we have our increasing and our decreasing intervals, okay? Increasing and decreasing intervals. How these work. Again, these are your pathways, okay? So this is my pathway on my x-axis. If y is going up or down, I just want to know where is x at, okay? What interval or what pathway is this at on the x? So, how I want you to view these intervals is we're going to have a person, and that person's going to be running, okay? So everybody say hi, Bree.
Hi, Bree.
Hey, Bree. Okay, so Bree's running on the line. Is she running up or down? So is that increasing or decreasing? Increasing. Okay. And we all agree that this line is going left and right forever. Okay? So her pathway on the x-axis for when she is increasing is negative infinity to positive infinity. Is she ever running downhill? No, so I'm just going to put none. Sometimes you'll have one or the other, sometimes you'll have both, okay? So if you don't have one...
How do you know she's not running backwards?
What?
How do you know she's not running that way?
Because we go from left to right.
Oh.
Yep, from left to right. Don't overthink it. Okay. Everybody with me? Okay. Now we've got Robert. Everybody say hi, Robert. Okay, Robert's running. He's going to start off. Is he going up or down? Up. Oh, wait. Now, what's he doing now? Down. So he has both, right? Where did I change on my x-axis? Ooh. -1. Because again, this is your pathway, right? So I already know that y is increasing and then y is decreasing. I want to know where at on my x is that happening. So if I look, Robert's going to the left forever. So he's starting off at negative infinity and going to -1. That's where he's increasing. And then he's decreasing from that -1 to positive infinity. Questions on that?
How'd you get negative infinity for the first one?
How did I get negative infinity for the first one? Because I know that this is going to the left forever. So it's from left to right. So it's starting at the left forever. It's ending at -1. And then starting again at -1 and ending at infinity for the decreasing. Okay? So go ahead, get that one written down, and I want you to try the next one. So try that absolute value one. All right, most of us got this one, and if we didn't, we just mixed up which one was which, okay? So if we look, let's go ahead. We've got Landon. Everybody say hi, Landon. Okay, Landon's running. That's his down. That's his decreasing. And what's that interval going to be? He's ending at 2, but write that as an interval. Negative infinity to 2. Negative infinity to 2. So from left to right, negative infinity to 2. And now, Landon's going uphill from where? 2 to positive infinity. Good. Questions on that?
Obviously.
It's okay if you got it wrong. Just make sure you make your corrections so you know moving forward what to do. Okay. Now, throwing it all together. Okay? We can do it. Throwing it all together. So I want you to do this one and the first one on the next page. After that, we'll go over them. We'll do the last one together, and we'll be done for the day. So go ahead and try that. Domain. From left to right. Where is this going?
Negative infinity, positive infinity.
Yeah, it's going left forever, right forever. So negative infinity to positive infinity. The range, which again is just the y, just on the y. Where's this starting?
2.
2?
Negative 2.
Mm-mm. Is it starting at 2? You were right. So if we look, this is where it's starting, and that's at 2. And where's it going?
Infinity.
Infinity. It's going up forever. Good. All right, so now I have, as x approaches, so we know x is going to the left forever, so we're going to start with that. When x goes left forever, what's y doing?
Go positive forever.
Up forever. Okay, then x goes to the right. We know it's going right forever. As x goes to the right forever, what's y doing?
Negative forever.
Nope, it's also going up forever. Questions on that? Okay. Then we got our increasing. Increasing.
What's that again?
So here's Chase. Everybody say hi, Chase. Okay, he's going down until when?
Negative 2. I mean 2.
Remember, it's your pathway. So on the x.
Negative 3.
Negative 3. Good. So from negative infinity to negative 3, that's when you're decreasing. Now Chase is going to keep running. Now he's going uphill. Negative 3 to infinity. Good. Questions on that? Okay. Whoa. All right. Go ahead and try this one. I'm going to give you about another minute or so because some of you have already started it. Get this one done.
Domain is left.
Okay. Domain on this one. What is it?
Negative infinity, positive.
Good. Negative infinity to positive infinity. Chase, let's make sure we're getting this down. Range, what's that?
Negative infinity to 3?
No.
Range is stupid.
Yeah.
Yep. 1 to infinity. 1 to infinity. Where I'm starting. Where I'm going. On the y-axis. Okay. We said x is going to the left forever. So as x goes to the left forever, what's y doing? Going up to forever. Infinity. As x goes to the right forever, what is y doing?
Positive.
Also going up, okay? Make sure, if those kind of confuse you, make sure you put your infinities on this graph. That's never going to hurt anything. So negative to positive, okay? Increasing. Here we have TJ. TJ's running. Okay. You going up or down, TJ?
Down.
Down. From where?
And negative infinity.
To where?
1. 4 to 4.
4. Good.
At what point does it fall in space?
Okay.
Around the halfway point.
Time to go uphill. From where?
4.
4 to infinity. Okay. Cool. Any questions on that?
No, we're not.
We're not done yet.
We're not in the last one.
Bo, I gotta go bed.
I've been waiting this whole time.
Nope, we're not, guys, we're not done yet. We have one more problem.
What?
We're just gonna do this one quickly, okay?
Can I please use the restroom after this? Chris.
Yes.
You're gonna be that guy?
Let's get through this problem.
After me.
What is this called?
And I asked first.
A function, a what function? Piecewise function. Brita said this is a piecewise function. So, how do I graph a piecewise function? It's in the title. Pieces, in pieces. Break it up, okay? So my very first one is y equals negative 2x plus 4. I'm just going to go ahead and graph that whole line. The b value is what?
4.
And the slope is? Negative 2 over 1. Okay, so I'm going to go ahead and draw this line. And I know that I only need this line when x is less than negative 1. Okay, so if I go on my x-axis to where x is negative 1, do we all see this? So I don't need anything where x is greater than that line. So I'm going to go back and erase. Okay, where I have those highlighted marks, you don't really have to draw the highlight, but you can. Okay. And I know that this is going to be an open dot. Okay, so I'm going to make it an open dot. So x is less than negative 1 is where this line exists.
Okay, but why do you have to erase that?
Second piece is what? 3. Y equals 3. What kind of line is that? Yep, a horizontal line where y equals 3. Okay, I could go ahead and I could graph this whole line and then go back and erase. Okay,
Where's negative 1?
or what I could also do is I could just look and see, where do I need this line? Between negative 1 and 2. So really I only have to draw it between negative 1 and 2 with open dots on the end. Okay? And again, feel free to use a highlighter if you want to. Just to like make these lines. So you can see, but you don't have to. What?
You connect them.
Nope, they don't have to be connected.
Are those both open?
Yep. Everything I've done so far has been open. Okay. Then we got the last one, which is y equals negative 2x plus 1. What's the b value?
Negative 2 or 1 and negative 2 over 1.
And then negative 2 over 1. So I'm just going to keep drawing that line, but I only need the part of the line that is
Greater than 2.
greater than 2 or equal to 2. So I'm going to keep a closed dot on that one. And then I'm going to go back and erase everything that's to the left of 2. And then I'm done. And again, if this highlight confuses you, you don't have to do the highlighted part. Just make sure you've got the function itself. Questions on that?
No.
Okay. So we're going to get an A on that on our test.
Probably not.
How are we gonna do that?
We are though. Okay.